Okay, for number 7, it says secant squared x over tangent to a third power x dx. So obviously here we don't really have like a composite function, right? So for this one, what we need to consider is like we see that there's secant squared x, right? And then also dx. So we're trying to see if like any of the other parts of the function when they take in the derivative of equals secant squared x. And in that case, we actually do have, we actually do have one, right? That's tangent x, right? I was gonna say that we do have composite functions, right? We have x third, and then y equals tangent x. We also have y equals secant x, and then y equals x squared, right? This is composite of x squared. This is tangent x composite of x to the third. But then the thing is, we have 2 of the composite functions, so you might not know like which one to choose from. So in that case, you need to consider what I told you about. So we have u equals tangent x, and then du equals secant squared x dx, right? And we have that already here, and then we're just going to say this equals to integral of tangent third x, right? Tangent third x is going to be u negative 3, right? Okay, and then we also have du, so we're going to put it like that. And then let's just take the integral, which would be pretty simple. Negative 1/2 and then u to the negative 2, right? Plus c. So that will be negative 1/2 and then just tangent x to the power of 2 over 1 plus c. Yeah, I wrote that weirdly, so just 2 tangent squared x plus c. So this would be the answer. Alright, and then number 8. We have a composite function one more time. So y equals x to the 1/3 power, and then y equals x minus 6. So this is the inside function, right? Okay. And then u equals x minus 6, du equals dx, right? And then, so it's just equal to du equals dx, and then we're going to try to rewrite this. So let's just rewrite this part. So integral of u to the 1/3 power, and then we also have du equals dx, so du. But the one thing we're missing is going to be the x, right? In this case, like, it's not like the previous examples where like when you take the derivative, the outside kind of comes with the derivative, and like you can replace it with a dx as well. But that's not the situation here, obviously, because derivative of x minus 6 is just 1, right? And then just dx. So something needs to be done, and then what you need to remember is that u is equal to x minus 6, so that means x is equal to u plus 6, right? So let's just plug in u plus 6 in the place of x, right? Okay. And then du, right? Yeah. Okay, and then let's try to expand this out a little bit. So u to the 4 over 3, and then plus u, or 6u 1/3 du. Take the integral of this, so that would give us, that would actually give us 7 over 3, u to the 3 over 7 times u to the 7 over 3, plus just 6 times 4 over 3 times u to the 4 over 3 plus c. Okay, so this gives us 3 over 7 u to the 3 7 plus 9 over 2 u to the 4 over 3 plus c, or 3 over 7 times x minus 6, 7 over 3, plus 9 over 2 times x minus 6 to the power of 4 over 3 plus c. So this would be our answer. And then let's go to number 9. So number 9, we have integral of x plus 6 over 2x plus 6, right? And then dx. So let's see. For this one, well, we don't really know which one, we can take the u of, right? For this one, I would say just consider, like, since this is a derivative, you're basically saying, like, it's 2x plus 6 to the power of -1. So that means you have the composite function y equals 1 over x, and then y equals 2x plus 6, right? So I think that means that you should choose this one, u equals 2x plus 6. So 2x plus 6 is going to be your du, and then to find the du, you want 2 dx, right? And then we can replace dx with 1/2 du, right? And then this is equal to 1/2, and then and then one over u, right? That's in place of 1 over 2x plus 3. And then let's plug in du, right? And then what about x plus 3? So x plus 3, I think, is going to be the same as the number 8 problem, right? So we see that u equals 2x plus 6, or 2 times x plus 3. So u over 2 is equal to x plus 3 that we talked about. Okay, so let's multiply u times 2 to this one. Okay, and that gives us 1/2 times 1/2 du, or 1/2 times 1/2 u, 1/4 u plus c, or 1/4 2x plus 6 plus c. Alright, and then the reason why this is able to work out in such a way, I would say, is because this one is basically equal to x plus 3 times x plus 3, times 2 dx. So this cancels out to give us 1/2 dx, right? And then you get integral of 1/2 dx, right? So you take the derivative, or not the derivative, integral, that gives us 1/2 x plus c, right? And then you might be wondering, that's not the same as what we got here, but then actually that is, because we get, if you distribute it, x over 2, or 1/2 x, plus 3 over 2 plus c. And then 3 over 2 plus c can be considered as, like, just c, because it's also a constant, right? Yeah. And then because the constant's not, like, defined, these two are technically the same answers. Yep. Honestly, I think it'll be easier if you just, simplify this into this part before, like, doing U-Substitution. Yeah, that way you wouldn't have to do U-Substitution, but then U-Substitution practice is still a good practice. So you can solve it either way. Okay. And then now here we have integral of secant squared times ln x all over x dx, right? So the inside function here would be ln x, right? U equals ln x, du equals 1 over x dx, and then luckily we have something like that right here, right? So we're going to say equals secant squared, and then u, right? And just du. That gives us tangent u plus c, or tangent ln x plus c. That will be our answer. Pretty simple, right? And then number 11 is a little bit more complicated, it seems. But, I mean, we know the inside function, which is u equals x squared plus 1, du equals 2x dx. We already have a form like 5x. That's a similar form except for the coefficient. So let's just divide everything by 2. 1/2 du equals x dx. Okay, so I'm going to put the 5 outside the integral. So 5, and then we also have 1/2, right? 1/2. And then we have our u value, u to -1/3, and then du. du replacing x dx, right? Okay, and then let's just take the integral of this. This gives us 5 over 2 times 3 over 2, and then u to the 2 over 3 plus c, right? Yeah. Okay, and that gives us 15 over 4 times our u x squared plus 1 to the power of 3 over 2 plus c. Yep, this is our answer. And then let's go to number 12. Yeah, and then we have our inside function of u equals 2x squared plus x minus 6, du equals 4x plus 1, right? And then dx, obviously. Let's see. And then we have something similar right here, right? We have 8x plus 2, which is basically 2 times 4x plus 1. Let's see. Let's just plug in what we know. So e to the u, and then we also have du equals 4x plus 1 times dx, right? So we're gonna have 2 times du, right? And 2 can go outside, so 2, and then e to the u du is basically just 2eu plus c, or 2e to the 2x squared plus x minus 6 plus c. This is our answer for 12, and then last 2 questions. We have like something like trig identity here. I think for this one we're going to be using 1 plus cotangent x as our u. That seems to be the most complicated thing. And then du is basically just going to be negative cosecant squared x dx. And we have that right here. So negative du equals cosecant squared x dx. So this is going to be equal to negative, and then u to the third, and then our du. Or negative 1/4 u to the 4th plus c, or negative 1/4 1 plus cotangent x to the power of 4 plus c. Yep, and then number 14, our last one, we got 3x e to the negative 2x integral dx. So we can say u equals negative 2x squared, right? This is going to be our inside function. Du equals negative 4x dx, right? And then we have a 3x right here, so let's try to divide everything by negative 4. So negative 1/4 du equals x dx. Negative 1/4, and then we also have a 3, right? We're going to send the 3 outside to match x dx inside, right? X and then dx. So we have negative 3/4 times e to the u and then du, right? That gives us negative 3/4 e to the u plus c, or negative 3/4 e to the negative 2x squared plus c. Okay, that's it.